Swayam Prabha. Digital India. Educated India.
Good morning everybody and welcome to our course on Introduction to Micromechanical Machining Processes. In the last class we started a new topic related to the component of the machine, and we have seen some of the important things that how the different component behaves, that will be dictated by the quality of the component which is coming out of the machine. In the last slide we have seen that there are different properties or different characteristics should be met during the machining or the fabrication of the machine tool. Those are the stiffness, thermal stability, damping property, accuracy, throughput and ease of use. So, getting these particular properties at what accuracy, that will be dictated by the cost of the machine. That means, if you want very high accurate machine, cost of the machine will be very high. Thermal stability means even a 1 degree change in here, your machine component or the construction component should not behave like a very soft material, then you have to use a very novel component or the novel material for making the different components. Cost will be very high. Stiffness is important because if you want to reduce the number of joints, then you have to create a monolithic structure. Creating monolithic structure also play important role in the costing. So, these are the different properties. So, now let us go ahead in this particular topic. So, what are the major subsystem of the machine tool? Because machine tool has a different components, but we have categorized a few components in one group and another in the other groups. So, let us see what are the things. First thing is the mechanical structure. So, this is a mechanical structure. So, here you can see that this is just a box type structure. After that you have to mount or you have to assemble many things here, right. So, this is by z axis. So, in this z axis what you will mount? You will mount a spindle axis and then you are putting a tools and many things on the top of it. So, in this particular box, in this axis you are putting a y axis, in this line you are putting a x axis. Once these things are over, then these are the, you have to install motors and everything to run these particular things. You need one sliding axis for the movement of the z axis up and down also. You have to mount spindle so that it can rotate. Other than this 4 axis, that is x, y, z and rotation around the z axis, you have to mount some supplementary axis also to getting more results related to the free form surfaces or 3D surfaces. So, mostly we work with the 4 axis, 6 axis. So, this is you consider, this one is the z axis, this one is the x axis, this one is the y axis, then the rotation around the x axis, rotation around the y axis and rotation around the z axis. So, rotation around x axis is called a axis, rotation around y axis is called b axis and rotation around z axis is called the c axis. So, many times machine has 6 different rotation and the translation motions, so that any complex components can be machined even at a micro scale level. So, machine structure or mechanical structure play important role, because here now you can see if these things are not perpendicular, it will create a problem. If this other than this perpendicular, if this is not exactly in the same plane, so then if it is a theta, then it is creating problem. The z axis is not exactly straight line, then there is a problem. If there is an angle and it is a rotation, then this whole structure is not perpendicular to each other. So, this should be maintained, right. So, creating a structure itself is very difficult, and when we are looking at micro scale machining, we have to pay more attention in each and every aspect of this fabrication process. Another thing is the spindle and drive system, because in micro machining we expect that spindle should rotate at extremely high RPM to get the productivity at the reasonably good level, because when rotating at a low RPM, what you have to sacrifice, that you have to sacrifice the feed rate. With low RPM, at that time tool will not continuously remove the material the way you are forcing the tool inside the material. So, your feed rate has the limitation because of the RPM, depth of cut has also limitation. So, if you increase the spindle RPM, then you have a large flexibility in terms of deciding the feed rate and the depth of cut at a higher level. So, there are different spindles available, some of them are belt driven spindles, some of them are the electric spindle, that means the motor is inbuilt within the spindle itself. You do not need a separate belt drive or some other pulley drive to rotate the spindle. So, we will cover all this thing in detail, but what is important thing of this part is the run out, because when you are machining at a micro scale, run out is the major thing which we have to look into it. Run out is very important to perform micro machining operation, correct. So, run out means whatever is, this is the axis of that, and then you have a run out of this. Your tool is, you are expected the tool is rotating here, but your tool is rotating at this axis. So, this will be in a few micron of radius, micro radian, but that is still enough to create a bed component out of the machine part. So, spindle and drive unit. So, what things you are using for driving this spindle, that is also important. That means the frequency response of that, how quickly you can reach to the spindle. There are vector control spindle available, so that every time when you stop the spindle, your tool is always in the same direction from where it is started. So, those things we will see in the spindle system, in different spindle system. Bearings are important, that which type of bearings you are putting and how many bearings you are putting, right. The stiffness is directly connected with these particular things, because we know that our tool is experiencing two forces. One thing is when it is going in the machine, at that time it is getting a normal force, and then you are moving in this direction. So, at that time it will get a tangential force, and your coupling is here at this location. So, when it is moving in this direction, there is a bending force comes into action, and when it is plunging inside it, at that time it is a thrust force, and this is when it is moving in this, it is a bending force. So, whatever is the assembly of this spindle, it should be able to resist this thrust force and the bending force while doing machining operation. Another thing is the control on the system, because we know that we are not operating any micro machining center by hand, because there are the controllers available, and each controller has a different, there are many machines available right now in the market which can perform the micro machining operation, but controllers are different for different machine. Many companies have their proprietary controller, so that you can perform a variety of tasks which is not available in the general purpose or the routinely available in the market. So, many companies have customized the controller. What things are important in the controller, what things you can do here, in the sense that suppose these are the programs. So, you can write the programs and axis movement here, and there are function available. So, each and every function key has a different meaning if you change the controller. Other than that, what is more important, that how up to what digit you are controlling the things. Now, if you see the current position is given here, target is given here, and distance to go here. Now, if you see this thing, it is moving from 0, 0, 0.1, 2, 3 and 4, 0, and mostly it is given in millimeter, right. So, if you consider this thing working very fine, then actually you are moving your component with a 0.1 micron, correct. So, if you are moving here, so this is the 4 point. So, you are getting a 0.1 micron of the movement. So, if you want to move your tool, suppose your tool is here, and if you want to move from this to this location, correct. So, this is, you consider it is a 10.02 micron, and you want to move from here to here 15.02, that is possible here in this case, right. So, here that is the advantage, that you are getting a different feel of that. Suppose if this is thing in millimeter, then what we are thinking of the 10.0001, that is starting point, and you are ending with a 15.0001, because that is what is showing that this is the precision of this part. But many times what happens, that your controller, this is a digital controller, that I will tell you in the next few slides, that how this thing sometimes is not the correct way to represent the things, because digital control can give value in terms of digit. Even you can add more to 0 also here. but whether you have to also say that whether your system is actually giving the feedback at that level. Whatever is movement of this thing, we have machine here in our lab, we will see in the demonstration class that they are also giving the last 4 digit out from 0 point you are getting a 40, but when you move the axis at that time it will move last 2 zeros simultaneously, that means you cannot differentiate between these two things. So, basically it has a movement resolution with a 1 micron only, not the 0.1, even though it is showing the 40 after a decimal 40 decimal point. So, your digital control is different thing, whatever it is showing in terms of this thing is different, and when your actual encoder is available, that is a linear encoder or the rotary encoder, what is the feedback accuracy of that thing, that is more important, that is the resolution of the feedback control is more important, the how small change you can detect there. So, that is important. Other than that, this is what are the some customized important things are there, that you can actually simulate the whole component here, because once you write a program you have to again verify that you have written a correct program. So, for verification of that, many times there are 2D simulator available, now machine controllers are available where the 3D simulations are available. So, this is 3D simulation where a face of a person is getting machine here, and this is the tool. So, before you operate the machine, you can actually verify your part program line by line, that where your tool is going to move, and finally what features you are getting out of the tool motion. So, this is very useful feature, so that you can actually reduce many errors. By chance if you have written something wrong here, you can actually rectify before you start the machine, and you have a chance to relook into the program efficiently. Then you can control the speed very efficiently, because suppose this particular thing is very important, because if you have set a feed rate of a 10 millimeter per minute, and by chance if it is giving some type of fluctuation, that your tool is not moving or it is creating something which is easy to inform, they are easy to get information out of that, then without changing the part program, what you can do, that you can actually reduce the feed rate of this particular thing. So, you can move from this is the 100%, suppose it is 100%. So, whatever speed you are rotating here, it will feed you are rotating, it will go up to 10 millimeter per minute, but if you move it to 50%, then what it will do, it will rotate or it will move with a 5 millimeter per minute, right. So, without changing a part program, you have a option or you have a flexibility, so that you can actually change the feed rate during operation. So, these things are mostly useful in the conventional CNC milling machine, where we have a possibility to correct the things during operation, but we have seen in the introduction section that hardly you can get any noise out of the machine, and visibility is almost 0, you cannot see anything, you cannot hear anything. So, this type of change in process changing, sometimes it is very difficult, but still it is useful when you can see the process there itself, and you can, by using of this machine, you have some expertise and you develop some knowledge. So, these type of things are sometimes useful in the process, and you have an emergency button. So, if you find that suddenly there is a fluctuation in the power or something, you can press the light, so then you can avoid the further damage to the machines. And there are some things available, that is called compensation of the error compensation things. Those things are important, because when you do some type of machining, you have a inherent error inside the machine, that is a expansion of the different parts, that is in x direction, y direction, z direction. So, machine can sense those type of expansion, and because of the sensor inbuilt inside the machine structure, and accordingly machine will take its own decision that what will be the situation of your tool if your temperature variation is within plus or minus 2 degree, 5 degree or 10 degrees. So, customized controllers are very important for a specific machine, but it should have a reasonably good amount of general purpose function, so that you can operate without any problem. Another thing is the measurement inspection system. That is very important, because we know that it is difficult to hear or difficult to see anything within the system. So, what we are getting, that we are getting some type of indirect signals. What are the indirect signals? That suppose you are putting something there. So, this is called the dynamometer. For force measurement. correct. So, what is the usefulness of this thing, that this dynamometer is mounted onto the work table and the workpiece is mounted on the top. So, this is the workpiece and this is the tool, correct. So, now when these things are in physical contact and when you are doing a machining operation, what happens, that you will get a force signal. So, this is the force in Newton and this is the time, correct. So, whatever is the situation, that means suddenly it is initially there is no contact and then you have started machining, so force will increase and then stabilize it. If it is within a particular band, then that means your operation is moving uniformly and within the safe limit, and suddenly if it is going up or if it is going completely down, if it is going up, there are different interpretation that your tool is on, and if it is suddenly going down and keeping 0, then tool is broken, right. So, these are one of the many interpretation by which you can actually understand what is happening inside the machine. So, this in process measurement by means of dynamometer or acoustic emission sensor or different type of accelerometer, those things are very important, so that you can get the information of the real time machining, because you do not have access to this location, but by this type of indirect measurement you can actually monitor the process or the status of the workpiece and the tool. Second thing is, the once machining is done, now you do not want to remove this particular component, because we know that we have fixed this component. After that we have decided our work coordinate system and the tool coordinate system, and once you misplace is this thing, that means once you remove it, placing exactly at the same location, you need again a very highly precise fixtures. So, it is better that let us not remove this component out of this workpiece. Once the machining is done, you put a touch probe that will do the calculation of the whatever things you have created inside that. Suppose you have cut a slot, this is the workpiece and this is the slot which is cut out of it. Then what you want to measure? You want to measure the what is the dimension of this in the lengthwise and the widthwise, and another thing is the what is the depth of this component, correct. So, these are the three things which you want to measure. So, this particular probes, there are many different companies who are selling this component. This is one from the Reniso. So, it touches the component at this location and then moves to this location. It calculates the what is the distance between these two, including the diameter of the particular probe, because probe has also diameter. So, this is the diameter of the probe, and if this is the surface, what is happening, that this particular thing should be compensated, because whatever is the diameter 1 millimeter, 5 millimeter or something, whatever is there, once it is touching that touch position, it should give the reading from this location, not from this location, correct. So, this is inbuilt inside that probe, but you should also know that where the measurement is being taken. So, it measures in this direction. So, it records this dimension, then goes to the center of this, then do the measurement in this direction. Or suppose you want to see the what are the different things at this location, then you can take more than one readings in the lengthwise also and the widthwise also. So, you can get one extra information that you have a perfectly square component or the rectangular component. Then third thing it will do, that it will go inside. First you have a height, suppose this is the side view of this and this is the component or the socket which is cut down from this, correct. So, first what it will do, this particular probe will go here and it will touch the top surface here and then take the reading, and then it will move here and then it will go here and then it will take the reading. So, whatever is the difference between these two, that will be the depth of the workpiece or depth of the feature which you have created. So, these systems are very useful and important, because now once this thing is done, you do not need to remove the workpiece. By chance if there is some error, then again you repeat the operation and get this thing done. If you remove the component, your work is very high, because again you have to realign exactly at the same location. If that is not possible, then you have to do all the calculation again, because that means you have to find the work location, you have to find that where you are going to start the operation, you have to find the reference position, then again you have to find out the what is the z axis compensation, that means you have to find a surface with a z0, then only you can go into the depth wise, correct. So, to avoid those type of reworking, it is better that you finish all the operation without removing the workpiece out of it. So, if that thing you have to do, then this type of measurement and inspection systems are very important, then that will reduce the time and cost also. Now, you can see here that how many different type of sensors you can put into the machining center. So, this was from the very old paper where it was given in a very generalized way that what things you can put into the machine, so that your machine become very intelligent. Now, if you see that your actual machining operation is here, right. So, this is your cutting tool and this is your workpiece, right. So, this is the actual thing, but you can add many sensors here, so that your machine you can actually give a more and more reliability to the machine. If you start from here, there are the sound sensors available, there are fume detect and some smoke detect sensors available, because if when you do machining operation at that time, there is a chances that you are removing at a very high rate. This is, we are not talking about the micro machining, but this is we are talking about the general purpose machine, all CNC machine everywhere. Sometimes you are machining at high speed machining, so your material removal rate is very high. So, friction is very high, fumes are also coming up. So, these particular things will decide that it should be within the permissible limit. So, when you are machining, you have speed sensors, you have current sensor, load sensor. That means, if you are going with a very high depth of cut, load on the spindle is very high. So, at that time you have to provide more current, so that it can counteract against the load. Torque sensor is available, so that you can find out that enough torque is available to cut the material. Acoustic emission sensor, pH sensor is available. pH sensor is important sometimes, because when you are using a coolant inside this location, then you have to maintain or monitor the condition of the coolant also. And once your operation of machining is over, then you put a surface roughness tester here and do the surface measurement here. So, without removing, you can find out whether your surface is polished completely or without free from any type of burrs or not. Lubrication detection, because your spindle is lubricated, it can also tell you that this thing is temperature sensor is available, because we know the temperature in the spindle is also important, because there are bearings available which are in physical contact with the races and other part. So, temperature should be within the limit. Touch sensors are available, because once your machining is over, your tool will go to this location and this touch probe will touch the tool and sense the tool is available, it is not broken. Tool wear sensor is available, these are non-contact, that every time once the operation is over, your tool goes to this one particular location, your camera will capture the image and then it will compare with the original captured image by this camera, so that you can get the difference between the used tool and the fresh tool, whether there is a edge blunting available, edge broken out is available, those things are possible. Edge position sensor is there, vibration type accelerometer, because when you do cutting operation here, there is obviously vibration between the cutting tool and the workpiece. So, some vibration will propagate it inside the spindle system and some will go towards the fixture and then it will transfer to the X and Y table and further to the base. But everything depends on the which is the construction material of this thing. That means, if it is a damping coefficient, damping property is very high, then what happens, it will damp or it will diminish this vibration within this particular local zone only, it will not propagate it throughout the system. So, vibration type accelerometer will tell you about the vibration level of that. Limit sensors available. So, when your tool is moving in this direction and unfortunately unluckily you do not remember what is the total travel limit of your table. So, your tool will reach to this location and then limit switch will trigger and it will not allow to move this spindle further in the direction. So, that is advantage, so that you can actually work within the safe limit. Seismic center sensors available. So, even some very heavy machines is moving from here to here, when you are transferring some machine, along with this machine you have mounted another conventional machine which is giving more vibration. So, vibration passing through the floor, vibration passing through the floor, that will also create a problem in our machine. Suppose our machine is working fine, everything is going good, but you consider the just outside of this machine installation, there is a highway going on and there are many heavy trucks which are moving very high frequency, high rate, so that you can get vibration out of that road to this location also. So, you have to make sure the location of the installation of this machine also, that there should not be any other conventional machine or the machine which has a very high tendency of vibration, it should not be installed there. There should not be any roads through which the very large amount of the more amount of the work vehicles and everything are moving frequently. So, you have to avoid those things. In this particular case, temperature, humidity sensor, pressure sensor. So, these things are related to the climate control. That means, you have to also maintain not temperature, but you have to maintain humidity also, because sometimes what happens, the moisture is actually captured by the different components of the machine structure, and because of that there is a degradation of the part. So, temperature distribution sensor is available, because now we know that when you do machining, at that time temperature is distributed into three different things. One is the within the tool also, another is the workpiece also, and third one is the chip, right. So, workpiece and the tools are located at the same location, but chips are actually spread all over the surfaces in around the X table, Y table and the base also. So, chip also carries a very large amount of heat, and when chips are falling at the same location, there is a chance that that particular location will be heated beyond a specified limit. So, you have to find out the temperature distribution also, that what is the total distribution of the temperature within the system. Chip monitoring sensors available, dust sensor is available, because many times we have seen that dust particle size is few tenths of micron, and our part geometry or what features we want to create, it has also the same dimension. So, when dust comes in contact with the tool and workpiece interface, at that it is considered as a one of the defect or some type of impact force from the external element, and that will create a problem. Precision thermal deformation sensor. So, here what it will do, what is the deformation because of the thermal effect, that means because of temperature variation, what is the deformation in the machine tool or the workpiece or the tool. Force sensor and torque sensor, that we have seen here, that is dynamometer, other than the strain gauge type of things also you can measure. Position sensors are available. Position sensor are mostly the linear encoder and the rotary encoder. So, we want to move from here to here, this location, the sensor will give you feedback that yes, actually your tool has moved from one location to another location within the required part. Clamping force is important, because when you are holding a workpiece here and then it is machining, so machining will create a vibration. So, if your clamping is not perfect or very firm, at that time your clamping will be little bit loose. After some cycle of operation, then this particular sensor will tell you that now there is a loosening in the clamping or the fixturing of the workpiece. Tool damage sensor is available, you can get continuous monitoring. So, there are few sensors which will give you the same reading, but more sensors are useful, because we are not sure about the reliability of the one sensor. So, if you are getting same data from 3 different sensors by 3 different principles and all are showing the same result, that means you are in a good shape. That means whatever the tool you are using, that is reusable for the next operation also. Then there are some other sensors available, that is called the lubrication coolant, temperature sensor, level meter. So, we know that we have to use coolant for that to reduce the temperature of on the tool as well as workpiece also and the chip also. So, when you are using that, first thing you have to maintain the temperature of that particular coolant also, because when you are recirculating this coolant, because of it is also absorbing the temperature from this working zone. So, it has also one temperature. So, if you continuously use the temperature particular cooler, at that time temperature will also rise from the cooler. You have to maintain the particular level also, because beyond a particular level the motor or a pump will not pass this fluid coolant to the working zone. So, you have to maintain those things. So, you can see here that there are different type of tens or hundreds type of sensor which you can mount onto the system. But now question is that how many sensors you really need for this, correct, because there must be a cost to the performance things, because now if you see here, so this is the performance graph and this is the cost, correct. So, now first thing we have to decide that what are the sensors which are important, because without that you cannot operate a micro milling machine. So, first you finalize those sensors only. So, then what happens that your cost will increase slightly with respect to the performance, that you are getting a performance very large here, but your increase in the cost is very small. Then you find out that what are the auxiliary sensors which are also important, and it play important role in getting some type of very costly components, because sometimes what happens that you are machining a very costly component, and this particular sensor, suppose you are reaching to this level, this is the consider the reasonably good point through which we can get the more performance with respect to cost. Now, you are using a very costly component or costly material. Materials, right. So, now what is the problem that even though you are using a reasonably good amount of sensors for getting a high performance, you do not want to create any type of problem with this costly, because if something happens to this material or during machining operation, what is the only way that you have to scrap this component, and that cost is even very high. So, what is the thing that you have to again add some more sensors here, right. So, now what is happening that now cost will actually follow a exponential curve. So, now you are adding some more sensor out of that, so that you can actually monitor the costly component machining, but still you are getting a reasonable amount of performance. So, now if you see this thing, then your performance and cost are almost same. The same amount of 10% of increase in performance, you are getting a 10 or more percent of increase in the cost of the machine. So, now what you have to do in this particular case, that now it depends on case by case. You have to find out that which particular workpiece you are cutting, what is the cost of this cutting, and what is the cost of the sensors which you are additionally mounting onto a workpiece surface. So, these things are very important in understanding. So, because you cannot mount each and every sensors into the machine tool, because machine has also limitation, that is a space, correct. So, whatever it is showing here, it is showing schematically, but it does not mean the location is the same whatever way it is showing here. It may be very crammed within a one location, you are putting 5 sensors, and then you are not able to understand that which sensor is giving good results. Assembly is also important, you have to cram many things at the same location. Again, it should not create any problem during machining, because even if you put many sensors here and some of the sensors obstacling the machining operation, then you cannot do a good job out of this thing. So, measurement and inspection systems are important, that we have seen here. Then tooling and processing technology. So, till now what we have seen about the monitoring the machine tool operation and the machine itself. Now, tool is also important, because we have to understand that how to monitor the status of the tool. When you are working with a micro tool or micro dimension, we know that it is difficult to detect the tool wear and the tool breakage. So, we need some sensory elements or some type of technology, so that you can get information of the tool without removing tool from the spindle. So, this is one of the tools. So, these particular things will give you one type of information about the tool edge. So, this is one type of lever kind of things. And when it is touching the surface, at that time it will be triggered one location. So, you can actually find out how, if there is any edge is broken or not. If you are putting this tool exactly from the top, at that time you can actually find out what is the height of the tool. So, in that way you can find out different properties or the specification of the tool without removing tool out of this particular system. So, these are some type of contact type of thing, that means tool is coming in physical contact with the sensors, and then sensor is getting the data for the further processing. And then there are cameras available, because once you complete the operation, what you can do that you take the image before using this particular tool. So, take the image, before machining, and once machining is over, you keep the tool in the same orientation and then take the image after machining, and then compare both the things. So, at that time you can actually understand how much is the tool wear, what things are there. So, this camera will give you a very nice pictorial view of the visual information, so that you can get information whether you can use this tool again or you have to replace the tool. right? And then there are non-contact type of things available. So, this non-contact type of things, here we are using a contact type of, but here it is a non-contact. So, how this thing will work? Right. So, now there is a source of the laser. So, this is going in this direction and there is a receiver. Source and this is the receiver. Correct. And now, what it is doing, the tool is actually moving in between these two. Now, consider that your tool is here and your laser beam is moving in this direction. Now, when tool is at this location, when it is gradually going inside it, then receiver will not get the signal. So, once it is not getting the signal, it understands that at which particular instant of that Z movement, this is the Z movement, that particular instant of Z movement your receiver is not getting the signal. So, that particular movement, because everything is synchronized, it does not mean that this is independently working, your spindle moving up and down is independently working, everything is synchronized within the controller of the machine. So, when you are not getting the signal, at that time it will note down that particular time, that when it is reaching that particular location. So, at that time you can find out the length of the tool, correct. Now, after that, what it is possible, that now it is inside of this thing. So, this is the length of the tool. Now, let us see from the top view. So, now this is the supply and this is the receiver and laser beam is going in this direction. Then what tool does, that tool is right now located at this location. It is already inside it, depth wise it is already inside, but little bit it is moving in the sidewise. So, again it is getting the signal on the receiver side, then tool will pass through this location. So, when it is passing through it, then when it is touching then this will not get the signal, when it is completely passed it will get the signal. So, whatever is the diameter of this tool, that much amount of time that your receiver is not getting the signal. So, by this way you can measure the diameter of the tool. Correct. So, length and diameter of the tool you can measure by this. Now, question is how small diameter and how small change in the length you can measure. So, there are different sensor systems available which you have to select. Suppose you are measuring with a more than 1 millimeter, then most of the system will work. But when you go down to the 100 micron or 50 micron or 20 micron tools, at that time the specification of this laser in this system changes, but systems are available where you can do the measurement of the online systems. Now, coming to mechanical structure of the machine tool. Now, what things are there? There are two different components available. One is the stationary bodies and these things are available. So, these are called the stationary body that we have seen in the structure part, that whatever the machine tool structure was, that those was the stationary part. And there are moving bodies available. Moving bodies are the XYZ axis and the rotation around the XYZ axis, and those things are movable components, so that you can get the required geometry machine onto the different components. So, stationary component, what things are included in this? The one is the machine base. So, this you consider the machine base. Correct. Column and spindle box housing. So, this particular thing is the base part. Then this column is this one, this is the column and the spindle box housing. So, this is the spindle box housing, whatever is available here, this is the spindle box housing. So, in that way you can find these are the few main components, but there are many auxiliary components depending upon the total specification of the machine, you can get the different things out of it. Then they are usually carry moving bodies. So, once you install these stationary bodies, then what we are doing, we are putting a different movable things, that is we are putting the servo motor or stepper motor for x and y motion, then you are putting the same motor for the z motion, you are putting a carriage also on the top of it, and then you are putting a different rotation around the axis also. So, those things are the movable components. So, your stationary body is important for carrying out this thing, and then you have to also make sure that all things are in a perfectly assembled. If it is not that thing, some loose connections are there, some perpendicularity, parallelism, flatness, those things are not there, then it will create a problem at the later stage. Okay, so let me finish this lecture from this slide. We will continue this topic in the next slide or the next lecture. Thank you very much.